My name is Regis James, and I have been working at Regeneron Pharmaceuticals for the last 10 years or so. And I've been building end-to-end AI workflow solutions essentially the entire time, but I've actually been doing that for the last 15 plus years in various areas. And today I'm going to be talking about the AI agent harness orchestration strategies that we've been implementing at Regeneron for scalably generating data-driven decision recommendations. It's a mouthful, but it's quite a few concepts that we'll be going through. So I'm also looking forward to hearing your questions at the end. So Regeneron's been cross-functionally innovating with AI for years. One example of that is the Magnetron AI workflow and platform that we have built, and we've been using it at a couple different of the sections that exist in Regeneron for the last several years. And you can see that the efficiency and output has been increasing over time. There's a dip in this most recent year, and that's just because there was an intentional decision to opt more for quality than for quantity. But it's a human-in-the-loop end-to-end platform. You can learn more about that at Data-Driven Decision-Making on YouTube. And this will also be there as well after that. But we are here to talk about how Regeneron is aiming the power of AI at increasing the efficiency of its clinical studies. So we're going to walk through one of those instances. And that instance today is Thiaa, which is an acronym that stands for the TMF Health Issue Assessment Agent. And TMF for Trial Master File. So it's for optimizing some of the processes that we do in the global development sector of Regeneron. So what I usually do when I give a talk is I start at the end and work backwards. So the targeted return that we're aiming for and we're on track towards is over $1 million in savings annually based on a few months of AI development work for the end-to-end platform. And the problem is that Regeneron's Trial Master File operations team is dedicated to continuous improvement, but in order to do so, reviewing all of the data necessary for making these data-driven decisions is very time-consuming. So the solution that we realized was that AI can quickly generate equal or better data-driven process improvement recommendations. And so the data, technology, and innovation group in the global development sector, Regeneron, has therefore built Thiaa. So previously and currently, so we're working on transitioning out of that process as we finalize the agent harness. The majority of the TMF department is spending at least 50% of their available time every single month to investigate the opportunities to improve the TMF operations workflows. And so this costs the company up to millions of dollars per year. So previously, their workflow included manually reviewing all business intelligence reports to identify improvable trial master file operations, and then exporting spreadsheets from those BI reports for the processes that appear to have opportunities to be improved, and then manually filtering and reviewing the spreadsheets in Excel. That's really painstaking, and it's challenging for them. And then, as they go through Excel to understand what the potential problems could be, so they're looking at the key performance indicators, then they're manually eyeballing it to identify, okay, these are potential problems, and then these might be the root causes of those problems, and then these might be the solutions. And so they have to repeat this process for all steps, for a variety of key performance indicators, for every single study monthly. And Regeneron, as many of you know, is doing pretty well in terms of our studies. We are moving forward, so that's quite a bit of studies, right? So to kind of zoom out and think of it at a higher level. So the manual trial master file work is review all metrics, and then export data for the processes that are improvable, and then profile the data to find the problems, root cause analyses, and then propose the solutions. And that takes 8 hours per study, per metric, and there's 10 metrics, so there's 9 others. It's just mentally back-breaking work. I mean, everyone's sitting in a chair, but that's also really not great for ergonomics and things. So this presented the challenges additionally, in addition to the manual work, but there's a different profiling recipe, and I'll reuse that term and concept as I go forward here, but there's a different recipe that can be done every single time. And that's due to the fact that there's variability in expertise and analyses across the department, which is a double-edged sword. The more expertise you have, the more things you can catch, but also the more variability you have, the less consistent you may be. And no fault of anyone, it's just that's how things can tend to be. It's, of course, time-consuming to interrogate the data, and it's very exhausting to manually identify trends. Keep things in your mind as you're switching, as you're slicing and dicing in Excel. It's just, our species didn't evolve to do that very well. So it's difficult to maintain consistency across multiple work sessions as well. Right? So if you are working on something and then at the end of the day you're thinking, oh, I've got to go home, I've got to go pick up my kids or something like that, then the next day you come in and you're thinking, wait, what was I doing again? So that becomes a problem. So the approach that we are working on is to have Thiaa be the AI agent to which a lot of this work is delegated to, but still with human in the loop controlling everything that actually is being done. So we're slated to get that time down significantly and drop from 50% of available department time to just 13% of it, which will bring the cost down to under $1 million per year. Right, so this workflow would include, or does include, working with the AI to agentically define and store a multi-step recipe. So it's like working with a human partner, but artificial, to identify which tables you should look at, how you should look at the tables, how you should slice and dice them. And so in doing so, the data can be investigated and interventions can be recommended. And then ask the AI to store the recipe and then use that recipe to generate recommendations as needed in the future. And then, after storing that recipe, repeat only the, hey, AI, can you give me recommendations based on the recipe that we previously stored? So just repeat that step. No need to recreate the recipes. So the benefits of this are that there's a single source of logic and consistency. Yes, that might mean that there could be some edge cases that are missed, but since it's an iterative process and we built it totally in-house, we can expand the awareness and capability of the agent over time as we find some of these edge cases. Another benefit is that it's fast. So it's minutes per study instead of hours for that data interrogation that I was talking about earlier. And there is effortless identification of trends because it's being done, again, agentically, so dynamically the SQL could be created and then pull things out of the database and identify what is relevant to be acted upon. And interactive visualizations as well, because there are side effects that are incorporated. It's like good side effects, the technical term in development, that are incorporated into how the agent works. So that you can ask it questions and it on the fly generates plots displaying that data that was retrieved via on the fly queries. And they're interactive visualizations as well. And then it's also consistent across multiple work sessions for the same study. So if you need to pick up your kids and you go home, you can come back the next day and just pick right up where you left off, as we've all become familiar with things like ChatGPT and Claude. So at a high level, right, so the Thiaa uses Regeneron's large language model mesh to extract data, infer trends that require attention, perform root cause analysis, and generate key performance indicator optimization suggestions. So it's actually, of course, not suggesting the optimization of the KPI itself, but the upstream process that results in that KPI becoming optimized. And then it also collaborates with the trial master file team to agentically define and continuously improve process intervention recommendation workflows. So there are fundamentally two roles in this new approach, which is an automation and agentification of the existing workflow. So there's the admin designer, which is the person who makes the recipe. And then there's the analyst, which is the study leader, the manager, who uses the recipe. So the admin designer is essentially working in the test kitchen, and the analyst is the customer that comes into the restaurant and orders that delicious meal of recommendations. So this is how it works, right? So there's the expression of the intent to the agent. It's teaching Thiaa how to recommend. So the admin designer makes the recipe by first shopping. So you can literally, and this is how I discuss it as I'm leading the team at Regeneron, you can think of it as you go to the grocery store and you identify, okay, I need carrots, I need potatoes, I need this and that. And so the agent, after you say, I need carrots and potatoes, the agent goes into the grocery store and finds those carrots and potatoes, finds the tables in the data lake and identifies which columns need to be used to cook the recipe. And then you transform the data. So chop up the carrots. I want to group this by this department or this CRO or whichever collaborator that we may have internally or externally that may be in some of the TMF data. And then cook. So this is the heaviest of the lifting because presently this is where the humans are manually looking at the KPIs and then looking at what's being sliced and diced and then thinking through, well, okay, is that acceptable or not? And then what could have caused it when it's unacceptable? And then how can we prevent that cause? So this is the cooking step that the agent does now on the basis of the training that has been bestowed upon the agent. A way I like to phrase it is also train the agent, not the model. Although we can do fine-tuning of models and things, that's possible. But in this case, when you're working within a harness, which is a modality of delivering AI agents and you're giving them access to different kinds of things, you can use a frozen model but then use that model as the brain for orchestrating how the agent works. And then you can train that agent by iterating on the skills, the different components of the recipes of how the agent should operate. And then you taste. So you evaluate the results of all previous steps and iterate if needed. And because of the way that we have built Thiaa, as you're tasting, as you're saying, okay, give me a recommendation for XYZ aspect of our TMF process, it shows you the data table that was retrieved from the data lake. It shows you plots. You can ask it, wait, actually, can you show me this as a pie chart instead of a bar chart? And can you explain why you did that? How did you do that? Because it's got access to the entire extraction process that it did agentically. It can answer all of your questions about how it did what it did, and then you can iterate on that and then adjust the recipe while you're still in the test kitchen phase. But once you've finished building that recipe, then you lock it in. Now it goes on the menu so that the other part of the team, that's after this, but the other part of the team can go in and place an order for a recommendation, and that order is cooked and prepared and delivered by Chef Thiaa because there's already been a locked-in recipe. So what this looks like at a high level is find data, generate recipe, test recipe, and then evaluate detected problems and recommended solutions. That's what the admin does. Now, in terms of the analyst that comes in and requests that Thiaa uses one of those frozen recipes, the steps are a lot different from how they were doing it before, but it doesn't exclude their decades of expertise that each one of them has. They are experts in their own right. It's just mentally backbreaking work for them to do it manually. So what they do is they come in and place an order, request recommendations for a study, and then they taste because they didn't have to do the slicing and dicing for 8 hours anymore. It's just minutes. So then they taste, they evaluate, discuss with the agent, which can answer all their questions because the agent executed the entire recipe, so it can answer everything, and then decide whether to act on the generated recommendations. And then take out. So they can say, great, Thiaa, I love what you're saying because I hate the KPIs that you found and I also want to fix them. So I agree with you, Thiaa. So then they take it out, right? So then they say, Thiaa, can you please send me an email of this? Thiaa automatically, agentically sends an email of the recommendations and the rationale, the basis and provenance of that. So at a high level, that means that the analyst goes in and requests a recommendation and then gets a coffee. And then they review the recommendations. And then they say, well, actually, I don't know if I agree with that. And so then they decide whether to implement or follow up with questions. That's it. So at a lower level, how exactly does all of this work? So Thiaa right now has 4 agents within it. There's a main agent, there's a help agent, there's a labeling agent, and there is a compression agent. And this is how they work. Now I have this is going to be on the data-driven decision-making, just at data-driven decision-making on YouTube. So you'll be able to look at this in a bit more detail if you want. But that's a lot of stuff that's going on. And actually, this is an important aspect because a lot of times in the news, the AI companies are saying everything is possible with AI, and then people believe everything is possible with AI because it's magic, but then that magic is made up of eye of newt and leg of this is all of the stuff right here. So there's a lot that goes into this, but I'll break it down. So for the main agent, you have an admin designer that goes in and provides intent for generating the trial master file process, intervention, recommendation. So the main agent goes into the test kitchen with Thiaa and says, hey, I want to make a new recommendation for XYZ aspect of the TMF process. So then that starts the timeline with Thiaa. Now, that timeline is able to progress because the IT department and the data science department that has done the data engineering to get that data together, that was previously used for the business intelligence tools, all of that has been brought together because the AI department that I'm in has built that harness so that the agent has access to all of this information. So they've provided the hardware and the data. Now, Thiaa receives that intent, not requirements. And that's actually an important concept that I think that should be discussed, the difference between requirements and intent. So a lot of times, non-computational collaborators might not be aware of what the literal requirements are for a system to exist, but they may know, this is what I want to happen. I want my life to be better because I don't want to take 8 hours to work on every single study. But I still want to know that the thing that I'm working on to fix the process will actually make the KPIs better. A lot of times that might be all that they can say. That's just intent. That's not the same thing as saying, I require that you have 4 different agents and I need 2 different database schemas. And so the translation of intent into a tangible asset that's reusable, that's a platform, that's partly the responsibility, in my opinion, of the AI departments and also the agent itself, further translating the intent from humans into something that is compilable and executable. So that's what Thiaa does here. Thiaa takes that intent and verifies its understanding and back in natural language to the non-computational collaborator who is the designer. And then the designer says, yeah, you got that right. Or wait, no, that's not what I'm saying. I'm actually saying this. Then Thiaa takes that in and then updates its understanding and then starts working towards building the sequel and the other steps of the recipe that we talked about before. And then it returns that to the designer who can then iterate on and lock in that recipe via the steps that I mentioned a bit earlier. So then the designer may or may not re-clarify intent, but if the recipe is to the satisfaction of the expert human in the loop who is the designer, then that designer notifies the people at the next stage of the pipeline who were previously suffering but no longer need to as much because they now get to be the humans in the loop that the baton is passed to, the study lead managers, or the analysts, right? So then the analyst goes in and says, hey, I just heard that you now have a good recipe. I'd like to order that off of the menu. And so Thiaa says, great, I will execute this recipe that's now been frozen as a skill. So as Thiaa is executing this, though, sometimes challenges can be encountered, right? And so there could be issues between what's happening with the execution, or maybe data could be missed. So then Thiaa agentically in the background notifies either IT or the data engineers or the AI department, hey, I encountered something that shouldn't have been happening. It doesn't align with the system prompt. So it sends that notification, which the teams can then go in and upgrade how Thiaa works or adjust the system prompt or the data set or what have you. But if all goes well, though, because the majority of the time it should, since the recipe has been frozen, then the result is given back to the analyst who then accepts the recommendations or requests for follow-up, and there could be iteration there. But, of course, as I mentioned before, there is the checkout, or the final step, where the recommendation can be requested to be emailed. And you can ask for it to be emailed to whoever because it has the ability to do that agentically. So training the agent does still require substantial human in the loop and iteration in terms of effort, but it dramatically reduces the overall time. Now for the help agent, it's a lot smaller and quicker. So this is a separate sub-agent that uses retrieval augmented generation based off of all of the user guide that was built agentically as Claude Code was being used to make the entire code base. So there's actually a whole separate sub-website inside of Thiaa that was generated, again, because Claude Code could see the entire code base. So it's a searchable user guide, but then there are also docs, there are change logs, architectural decision records. All of this is available to the help agent. So then the help agent can now answer any questions that anyone has about how to interface with Thiaa. So there could be someone that goes in and says, wait, actually, I'm not exactly sure how to do this. Can you tell me? So it can tell the person, but it can also, as, again, a beneficial side effect, and this was inspired because I saw recently that another help agent in another platform was able to operate the interface of an app that I was using. And I thought, wait, why not incorporate that into this as well? So we led the team to do this as well. So it can provide guidance on how to use things, how to interpret some of the outputs, but also you can say, hey, can you open this or open that aspect and put this in and put that in it, and the help agent can do that as well. So that accelerates that aspect of the process. And then it can also, if it encounters issues, it can on the back end agentically notify the appropriate parties if any challenges are found, and it can give recommendations on how to fix them. So it helps to reduce the problem solving time. So the labeling agent, it's a quick thing that you've all seen, which is that whenever you start a conversation with ChatGPT, for example, if you say, hey, I want to know how to make chocolate chip cookies, can you give me a recipe? When you start talking to it, it labels the conversation so that when you come back later after you, again, pick up your kids from soccer practice, right, the next day you can say, okay, what conversation was I working? I know it was something with cookies, but now you can filter to the historical conversations to the ones about cookies because that label has been there. So that's also been incorporated into this, simplifies future retrieval of past work. And then one of the really important aspects, which is the compression agent, because all of large language models have a limit to the number of tokens that they can have. So the main agent is constantly watching to make sure it's not getting too close to that limit. But when it does get too close to the limit, it just sends its whole context window to the compression agent, which figures out how to compress it and summarize everything and then send it back into the main agent. And then the user continues on the conversation, none the wiser, and everything flows without anything exploding. And it enables work to continue without hitting that limit. So some of the sustainable impact areas, right? 75% reduction in time and cost via these workflows. There's a reproducible problem detection and recommendation generation via these recipe design workflows. And then it's scalable minimization of solution support needs because it makes the AI self-sufficient via these agentic error reports that I was telling you about. Also, admin overview of historical conversations because that makes it possible to continuously improve how the harness works. And it also has that help agent that I was discussing, which can directly operate Thiaa's interface, and it can leverage the comprehensive knowledge base that's generated on that code base by Claude Code. And it also agentically emails the appropriate support team people if there are gaps in that knowledge base. So we've got the help agent, the user guide, the change log, and we also have aspects of observability in terms of admin oversight, conversation reviewer that I just mentioned. There's also a usage viewer, so it's possible to see which departments used it, how many people in those departments, when they used it, because that can inform resource allocation. And then admin oversight, error reviewer as well, and the recommendation reviewer. And then additionally, it's possible to simulate different users so you can see if they encounter any issues, how that may have happened and how it can be rectified. And then there's also agentic evaluators of consistency as well. And by that I mean how often is the same recommendation given as the output based on the same input, because this is non-deterministic and probabilistic, so it's not always guaranteed. But yeah, it's taken a village to lead this effort, but it's looking like the future is pretty bright. So thanks.